Alright, so we are still on torsion. Let's consider the question on the board. It says a circular shaft of 50 millimeter diameter is required to transmit torque T from one shaft to another. Question says find the said torque T which the shaft can transmit if the allowable shear stress is 40 megapascal. Okay, so let's get down our given parameters. We were given that a circular shaft of 50 millimeter diameter. So we have the diameter. Okay, we were given diameter D to be equal to 50 millimeter. And of course, always convert your values to ground units. So simply convert 50 millimeter to meters. You divide by 1000 or multiply by 10 to the power of minus 3. That simply gives us 50 by 10 to the power of minus 3 in meters. Okay, so required to transmit torque T, the torque is unknown. So torque T is actually unknown. Okay, question says we should find the set torque when the shaft can transmit, okay, which the shaft transmits if the allowable shear stress is 40 megapascal. So we're given shear stress. Okay, we're given shear stress tau, simply 40 megapascal. And of course, we can convert this to Newton, simply 40 by 10 to the power of 6 newtons per meter square. This becomes the shear stress acting on the torque. So the question is asking us to find the value of T. So once again, we employ the torsion equation. So recall that T all over J from torsion equation, T all over J equals G theta all over L equals shear stress all over radius. So we assess the given parameters and quantify to see if which of them satisfy the given condition in the equation. From the question, we were given diameter, which means we can find the second polar moment of inertia, which is J. We were asked to find T, so automatically we are going to make use of this part of the equation. We were also given the shear stress, and we're given diameter, which means we can find the radius. So we don't know this other part, so which means we can only equate these two, this and this equation, to be able to find the value of the torque. So making use of, okay, using simply T all over J equals shear stress all over radius. Okay, so like I said, we have the diameter, so which means we can find the radius. From D, equals 50 by 10 to the power of minus 3 in meters, we can simply find radius. R is simply diameter all over 2. So which means the radius arm is actually diameter is 50 by 10 to the power of minus 3 divides by 2. This simply implies that the radius is given as 25 by 10 to the power of minus 3 in meters. This becomes the radius of the shaft. So R is obtained. Next is to find the value of the second polar moment of inertia. And of course, we know that J is actually pi diameter 4 all over 32. That gives us the value for the second polar moment of inertia. Okay, so this is actually equal to pi is given as 3.142. Diameter was given as 50 by 10 to the power of minus 3. So simply 50 by 10 to the power of minus 3 all to the power of 4, because we have diameter 4 here. Okay, all over 32. So this simply implies that J is actually equal to, this is 3.142 multiplies, please give me 50 exponential 3, 50 exponential minus 3 all to the power of minus 4. Okay, so 50 exponential minus 3 to the power of 4 gave us 6.25 times 10 to the power of minus 6 all over 32. So J is equal to, multiply that value by 3.142, we have 1.2 96375 by 10 to the power of minus 5 all over 32. So simply divide this value by 32. This simply gives us j is equal to 6.136. Okay, simply 14 by 10 to the power of minus 5 by 10 to the power of minus 7. Okay, in meter 4. So this becomes the value for the second polar moment of inertia. So obtain J, we know the shear stress, we know the radius now. We can simply now find the value of the torque. If we make torque subject of the formula, simply what making T subject, send polar moment of inertia over to this side, it becomes J times shear stress all over R. That gives us the value for the torque. Okay, therefore T is actually J multiplied by shear stress all over the radius. That becomes the value for the torque. And this is now equal to the polar moment of inertia was given as this 6.14 by 10 to the power of minus 7 multiplying by the shear stress. Shear stress was given as 40 by 10 to the power of 6. We'll have here 40 by 10 to the power of 6 all over the radius, and we obtain the radius of be 25 by 10 to the power of minus 3. 25 by 10 to the power of minus 3. Okay, all right, so the torque T is now equal to 6.14 exponential minus 7 multiplies 40 exponential 6. So T is equal to 24.56 all over 25 by 10 to the power of minus 3. If you do this, you're simply going to obtain the torque. Alright, so that implies that the torque is simply 982.4 kilo, okay, newtons meter, rather, newtons meter. Alright, so that becomes the torque T transmitted by the shaft, okay. Alright, so I hope you find this video interesting. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you're new to the channel, please tap the subscribe button to keep getting updates when contents like this drops. I will see you in the next video with more problems on torsion equation. Thanks.